Hey everybody. Okay, I'm gonna try to get this a little bigger on my screen. And let's full screen it. So you are working through your Earth's energy budget and the greenhouse effect notes. You should have this paper. Okay, you have this paper. It has this drawing thing on the back. We'll get to that after the notes part, okay? You need this paper and you need to be able to hear me. Okay, so here we go. Earth's energy budget and the greenhouse effect, and it shows some sunlight getting all the way down, some reflecting up, some going around. Okay, this is what we're talking about. So we already know from our electromagnetic notes that solar energy includes the visible light we can see, the infrared that we can't, and the ultraviolet that we can't. Just a little ultraviolet gets through. And solar means sun. So, visible light is all the colors you see in the rainbow. Ultraviolet is shorter, infrared is longer. Okay, those visible ones go in order of Roy G. Biv. Okay, when we talk about infrared, then that means the wavelengths are even longer than red light. And remember that a wavelength was how far between the two wave tops, right? And so it means that the red are kind of a softer one and the purple or violet are more straight up and down, right? So infrared is invisible and we feel it as heat. Okay, an infrared camera shows us where heat is coming from, okay? Ultraviolet is on the other side. It's also invisible, but it has shorter wavelengths, okay? So it's on the shortest side, and it can cause sunburns, skin cancer, and even damage your eyes. If you've ever known somebody who had something called glaucoma, things like that, we can get kind of like a sunburn inside our eye over time. It can cause us problems. It can even damage your eyesight. Okay, now you have some idea of what a budget is. And let me remind you, like if you didn't get everything here, pause me, rewind. This is why it's a video, right? Make sure you're getting everything you need for this paper. Okay, so you know what a budget is. Usually when we talk about a budget as people, it's about money. So how much money do I have to spend this month? How much can I spend before I have a problem? Yada, yada. Okay, you're starting with kind of a limit. Okay, when we say Earth's energy budget, we mean that the amount of energy available on the Earth is limited because we only have what we get from the sun, essentially, for the most part. Okay. So Earth's energy budget shows how energy flows into Earth and away from Earth. Just like my budget for the month might show how much money I got and then how much I spent and how much bills I paid and whatever. When we look at this, we're looking how much did the sun give us, 100% of the energy that we get, and then how much got sent where. So notice you're now on the back, on the drawing, filling out the drawing, okay? 25% gets reflected by clouds, dust, other gases in the air. It never makes it through that kind of top layer. 5% makes it all the way down but bounces off the surface and goes back out the atmosphere, back into space. About half of all the energy from the sun is absorbed by the surface. Have you ever been on a sidewalk or even at the park, like with the grass or anything, put your hand down or sat down and the ground was warm? A lot of that is because it's absorbing it from the sun and then it slowly releases back out. It heats up the land and the water. Okay, 20% is absorbed by gases and particles in the atmosphere. So here's the difference. Reflected by gases in the atmosphere means it bounced off, like your reflection on a mirror comes right back. But absorbed means that those gases got warmed up, okay? This matters a lot. How the sun's energy affects the atmosphere is going to affect our weather and climate, okay? Now, I want you to understand something. This little 6% here that just popped up, so see the difference? That's where the 6% popped up. It means 6% of this half. means 6% of that 50. Okay, so we're breaking down that 50%. Okay, about 6% is radiated from our surface. Like I said, it kind of can release that back out. You can feel warm concrete, right? Releasing it back out. And then let me go back so we can see. Now we're looking at the other 44, because 44 plus 6 is 50. So the other 44% of this that gets absorbed by the Earth's surface, and they're showing 20% of this 20%. Both of those are going out into the clouds and the atmosphere. Okay, so we're adding it together. 64% ends up eventually radiating back out into space. Again, I want to make a difference here. Reflected into space happens right away. Boom, boom. What's happening with the radiation is something gets warmed up and then it slowly releases that heat back out. Think about if you microwaved a mug of water in the microwave to make hot water. If you let it sit there, even though it's hot now, all that heat will radiate off until it's not hot anymore. That's what the radiation means. It's different from reflection. Okay? Why is the energy budget important? It determines our climate. Okay? If we give off less energy than we receive, then the Earth will heat up. So, to go back to the picture, if all of this doesn't get radiated out and reflected out, then it's basically like if I didn't spend all my money this month, my savings will grow. Now, for me, that would be a good thing. But for the Earth, saving up heat will cause it to warm up, and that will mess up our climate. It is messing up our climate. Okay? If we give off more than we receive, the Earth would cool down. This happened during the Ice Age, or other times where if the Earth is covered in bright white, or if there have been times in Earth's what we call geologic history, meaning the long, long, long history of Earth as a rock, not a place where things lived, but as the rock itself, that is Earth, where volcanic activity, if the whole atmosphere fills with dust, and the dust is reflecting the sun's energy back, then the Earth can cool down, and that can cause an ice age. Okay? So different circumstances can cause the Earth to save up heat and hold on to heat, which makes it too warm, or reflect out heat, which makes it too cold. People trying to help us with climate change are trying to find ways to help the Earth reflect light back out and reflect energy back out more so we can even it out again. We call Earth's ability to reflect that out albedo. And we can do that, and people are doing that by painting the tops of buildings bright white colors, trying to increase the surface of the Earth that is bright and white so it will reflect more so we can get the budget back into balance. Okay? And so if you look at this diagram, this is showing you the greenhouse effect. So a greenhouse is literally one of those clear boxy houses, not really a house, like a shed, where you grow plants who need it to be warmer, but it's not warm enough outside because that greenhouse traps that heat like a blanket. The heat from the sun gets trapped inside that greenhouse. That's what happens to a planet when the atmosphere is causing it to hold on to more heat. We talked about how Venus is the hottest planet. Venus has an intense greenhouse effect. For example, this is natural and it's important because like we said about Mercury, if your planet has no atmosphere, then it will just be dead freezing cold and the atmosphere will not be manageable. And then on the sunny side of the planet, it will be boiling hot. So having this atmosphere blanket is important and allows us to live here by managing the temperature. But if it gets even a few degrees out of whack, everything on Earth is so used to a very certain temperature, things go wacky when that happens and we get a lot of problems. Okay? So it balances out our temperature, but now we've gotten the balance off because like the carbon in the atmosphere that we've gotten a lot there is causing it to hold on to more heat and throwing off the balance. Okay, so we only get a little bit of the energy from the sun and it powers the winds, the currents of the ocean, photosynthesis, the food chains, everything. Just that little bit that we get from the sun, that's what it does for us. It's huge for us. It's what keeps the planet going. But we're holding on to a little too much of it now, and it's causing us big problems. But there's lots of solutions, and it's getting worked on. And I'd be happy. We're going to be talking about a lot more of those solutions as the year goes on. Hopefully you filled out both sides of this. You need to make sure that you did. Rewind if you need to. And that paper goes in your binder. Put it in your binder. Okay, thank you. I need to come out of full screen, and I want you to put this safely in your binder and then keep working through your module. Next on the list.